All right. Okay, so this is the point that I was making, that there is no point in reinventing the wheel. You need to know what is out there and you need to build up on that knowledge, right? So why you should do an extensive literature survey? To not reinvent the wheel, for sure. And also these things. To familiarize with the existing body of work in the field, you need to know what's happening in your area of work. You need to identify the key contributors, right? To expose yourself to different approaches of thinking. You might be thinking about the problem in one way, but that's not just the only way. There are several other ways of doing it, and simpler ways even perhaps. The more you read, the more you try to look and understand the way of thinkings of other people, other scientists, you get a much broader way of thinking, right? And of course, to identify the knowledge gaps. This last point is particularly important for masters, MS students and PhD students. At the end of the day, you are required to add to the knowledge. You have to do something new. You have to show that you are capable and independent researchers, but also that you're able to add to the body of knowledge. So that's why you need to identify what are the knowledge gaps, right? So this means that you need to develop new ideas. So once you see what's out there, you see how people are thinking, you say, they didn't think about it in this way. So then you'll develop new ideas, and then finally to make sure and defend that your idea is truly original. The worst thing that can happen is you don't do your literature survey properly. You say, this is the best literature survey I've done. You go and present somewhere and they say, this is already done by a Russian some 50 years back. This is the importance of literature survey, right? Even those papers are now available as translated papers. So you really, really need to look at all sources. Right? This, again, is important for MS and PhD students. You need to establish your expertise in the field. If you don't know what's happening out there, and if you'll not be able to develop new ideas, you won't be able to defend your own research. You are not an expert. If you want to be an expert, you need to know absolutely everything that is pertaining to your narrow field. That is fine. But you must know what is the nut and bolts of your field. Right? So you need to establish your expertise, and literature survey helps you to do that. Now comes the how. Okay? So how are you going to do it? You need tools like Mr. Rajnikanth here. You need to be ready with them. And so let's get started. And let's start with the obvious, the Google Scholar. Okay? Everybody uses it. There is no shame in using it anymore. But the point is, it is also very fast. It gives you a lot of information. And even that Google Scholar is enough if you know how to use it properly. So let's quickly look at Google Scholar. So again, I've just searched for gravitational waves here. And here you can see that this is the search bar, right? Then you have, you can select which time window you want to see the papers from. Like I said, papers are published at different points in time, so you can select which time you want to see. You can even specify a custom range. You can sort by relevance, or you can sort them sequentially, latest first, oldest later, something like that. And finally, when we are looking at the journals themselves, if you click on these journals, then you can find you go to the journal site, or you could also download the paper directly. This link is very, very useful because sometimes we don't subscribe to certain journals, but some professor might have just uploaded it on their own repository, so you can download it from there, right? Then comes the citation. So this is how many times people have used that paper to work on their own and advance knowledge on the basis of that paper, right? So that is the number of citations. And these are called forward citations, or at least I like to call them forward citations because they say that this paper already exists. I'm citing the paper, so it's a forward citation, right? Now, if I click that forward citation, it again opens up a new page, more number of journals, all right? And at this point, we have to start thinking which journals to choose. So the number of citations is often a good indicator of a good paper, but there are further metrics also. Number of citations for sure. If a paper is cited 1,000 times, at least it's worth a read. Okay, you have to then evaluate whether it's useful or not. But then you have to also consider other metrics. Okay. So what are those metrics? First of all, it's the author profile and H index. So if you go, let's just go back one step. And if you see here, if you see the first journal, CM Will is underlined. The author CM Will, Living Reviews in Relativity 2014. The CM Will is underlined. If you click on CM Will's, you'll get the full Janampatri of what papers he has published, right? He or she, I don't know. So what I'm showing here is the same kind of a scholar profile, but for a person I know in my field. So what you can see or what you can gather from this author profile. So first of all, some of the basic stuff, you know what is the affiliation, you know what are the number of citations he is citing, number of citations across the papers, as in he has written a lot of papers, how many times those papers have been cited, number of years active also. So there is this bar graph on the right, and you can see that he has been fairly active over the past couple of years. And these are also some important metrics. Okay. So first of all, you have got the H index of the author. And what that means is if an author has an H index of N, it means that N of his or her papers have been cited at least N times. Okay. That's a very useful metric. There are caveats. I won't get into that for now. That's more advanced stuff, and that's a point of discussion. But for a beginner, for a person who is starting the literature survey, this is a metric that you can rely on to start your literature survey. You've got the I-10, which is very Google Scholar specific. It says that it's the number of publications with at least 10 citations. Okay. So in this case, you can see that the H index of the author is 64, which means that he has got 64, at least 64 papers, which have been cited 64 times. That's no easy feat, all right? So he's a very good person, like a very good scientist, and also a very good person, by the way. And I-10 index, he has got 321 papers which have been cited at least 10 times, all right? So again, he's like one of the mammoths in the field. That's why I got these numbers. But if you take a younger person, he is also someone known to me, and he's a colleague. And he started his research somewhere in 2013, 14, right? So now you can see how the profile builds up on the bar graph. And you can also see the H index. Now you can do further analysis and all that, but then for starters, H index 8, 9, 10 is already good, okay? A good PhD student, a good postdoc will already have like a 10 or an 11, typically. That again depends on your field, all right? So again, ask your supervisor whether this author is good or not. What's the second metric? The journal impact factor. You need to weed out, you got, as you saw, there were 835 citations for that particular paper. It is impossible for you to download all of them and just even go through the names. It's going to take a lot of time. So you need to be able to weed out which publications are good, which publications you can set aside for now. And the journal impact factor, again, is one of those things which is, there are a lot of discussions around it again, but you can start with the journal impact factor. And what does it mean? The journal impact factor is the mean number of citations of articles published in the last 2 years in a given journal. So over the last 2 years, you find if it basically says that a given paper would be cited at least these many number of times, right? So if you look at a couple of examples, Nature, Science, Lancet. So which means that if you publish a paper, or if it's a paper from, let's put it this way, if it's a paper from Nature, there is a good chance that it would have been cited at least 42 times or somewhere in that range, all right? Which means that it's a high impact paper. If you look at, I don't have the numbers for biological papers like cancer research and all that, those numbers go into hundreds, all right? But these are some of the more common ones. Again, this comes with a caveat. What is that caveat? Let's look at some special cases, all right? Scientific reports, when it came out, right, it was a really, really good paper. It was a really, really good journal where people used to submit their scientific research. As long as the science was correct, the paper published it. And it had an impact factor. When it started, it was around 10 or 14. Over the years, the impact factor fell. Right now, it is around 4. What I'm trying to say is, if you find a scientific reports paper now, and you look at the impact factor now, also check whether the paper you're reading is from now, right? That's one example. There is always the time aspect to it. Astrophysical Journal has an impact factor of 7.4. Now, the Astrophysical Journal is a discipline-specific journal. It's a highly respected journal, all right? Even if the impact factor is low, it doesn't mean that it's a bad journal. It's actually a very respected journal. So this is something you develop over a period of time when you start looking at papers. Look how many times a particular paper has been cited. You will understand which journals are good. And finally, conferences. Let's not forget conferences. Some of the conferences have got a very high impact factor. This will be particularly relevant for our BTech and master students or PhD students, even who are working in the area of computer vision or AI and artificial intelligence and deep learning. There might be conferences which have got a much higher impact factor than the journals themselves. So that's why the journal impact factor is a bit of a dicey thing, but again, for starters, you can use that as a metric. Okay. Predatory journals. Now, how many of you here are aware of predatory journals? Okay. Online, can I have a show of hands? How many of people are aware of predatory journals? Okay, fine. All right. Okay, we have got a couple. Good. So we have to be very careful. Sometimes we might think that a paper is really good, reading its title, reading the author list, even sometimes reading the author list. But it may turn out that it's coming from a predatory journal. And what is a predatory journal? It's essentially a sham publication. Okay. It's only recently that they have put together a definition for a predatory journal. And it basically says, let me just read it out for the purpose of the audience. Predatory journals and publishers are entities that prioritize self-interest at the expense of scholarship and are characterized by false or misleading information, deviation from best editorial and publication practices, a lack of transparency, and or the use of aggressive and indiscriminate solicitation practices. So what this basically means is, these are just sham journal houses. Suddenly they'll write you an email saying that please submit in our journal, we publish it. And once they accept it, the peer review will be done in 2 days. And they'll say, sir, your paper has been accepted, pay 5,000 euros, and then we publish it. And they'll say, no, I won't. And basically they'll just kind of go at you, and there is no peer review. There is no, it's just publishing once they get the money. And they go to some really extreme extents, okay? So if you look at the Wikipedia page, it's highly detailed. They accept articles quickly with little or no peer review or quality control, including hoax and nonsensical papers. They notify academics of article fees only after the papers are accepted, and there are also fake impact factors. Right? Now you're working in this sea of confusion. How do you know which journal is a good journal, which journal is a predatory journal, right? Thankfully, people have been working on it. And I strongly recommend reading this link. It's a Nature letter or a Nature article. And in that, they have put together the different lists that you can use to identify whether a particular journal is a good one or whether it is a predatory one. All right. So you can look at it in much more detail. The first person to actually do it was this guy called Beals. There was some controversy surrounding it because he was just blacklisting papers. Some people took the approach of whitelisting papers and saying that these are better journals. So DOAJ is another list where they just highlight the good ones. And so you can compare. If you are at any point in time you have a doubt, then you can refer to one of these lists. At the end of the day, again, you can always approach a supervisor if you're not at all able to make up your mind, because maybe the material is good, but the journal is bad. You don't know. So ask your supervisor. Right? So predatory journals are very important. You must know which ones are those, and you must not make it part of your literature survey. Okay? Fine. Yeah. If in doubt, ask your supervisor and guide. So, how to kickstart your literature survey? And we are at the half mark. Fine. How to kickstart your literature survey? find a good review paper. Okay, so, and find a good review paper with the following attributes, which has a good number of forward citations, is from a reliable author, is from a reliable publication, and it has been published recently. Okay, it can be within the last decade. That is also okay, because a literature survey or literature review actually goes back to the past, and it goes back to like 50 years, 60 years. That's always the mark of a good literature review. You can start from a recently published literature review, right? And if it's within the last decade, what you can still do is you can collect the backward citations, which are the citations in the paper, and you can find the most recent papers in it and look for their forward citations. Okay, so that's how you can actually kickstart your literature survey. One more important thing that you need to do at this point is you need to catalog the main authors, the main journals, and the conferences. You'll immediately get an idea of which are the journals where people are typically publishing in that field, and you catalog that. And why I have highlighted it, it will come next, right? And you start building your library using a reliable reference manager. Okay. Now, what is a reference manager? So we saw that this particular paper, just taking a random example, it has got 835 forward citations, right? Too much to handle. You cannot keep everything in your brain, fine? So you need to kind of develop a second brain where you shove all of them, shove all your citations there, and then you build your library. And that's basically what a reference manager does, okay? And I take the particular example of Zotero because I have used Mendeley, I have used NVivo, I've used different kind of things, but I have found this to be the most useful because you can very quickly draft things. So Zotero has got a plugin in for your browser. It has got a plugin for Word, and I have found it to be much more easier than Mendeley. So Mendeley, a lot of students are using Mendeley, but I recommend you give Zotero a shot. It's simpler to handle. Okay, and the facade of Zotero, if you open it, looks something like this. So this is actually, well, it's not too private, it's fine. And you can see that there are a lot of folders that I've created. So each folder has got a lot of journals in it. So you're looking inside one of those journals, and it has got a couple of, one of those folders, and inside you've got a couple of journals. If you look at the extreme right panel, I have highlighted the first journal here, and you can see all the details about that journal. So you've got the author list, you've got the abstract, and then if you proceed further, you also get, yeah, it's going further to the abstract, and you also have all this additional information. Okay. Are we typing it in? Clearly not. 835 citations, there is no way we are going to do it. So how do we do that? What we do is we use Bib Files. Okay, Bib Files are going to be your friend. I'm telling you. So if you're working in LaTeX, you already know what are Bib Files. If you're new to the research field, familiarize yourself with what are .bib files, BibTeX libraries, and bibliographies, right? So how to add journals to your reference manager? The first thing you can do, this is the more technical way of doing it, you download the .bib files itself. And how do you do that? You go directly to the journal web page. Now there are people who would go to Google Scholar. There is an option called Cite, and from there they'll download BibTeX. Please don't do that. Okay, it is going to give you really badly structured references. The best place you can get a good .bib file is directly from the source, which is the journal web page. Okay, so you go to the journal web page, you download the .bib file directly from there. You look for the download citation option and download the citation with the .bib extension. You'll have different kinds of extensions. .bib. Go for it. There are .res, and you've got text, you've got plain, just you can copy paste. Download .bib. Okay, and import it into your reference manager. All right. So if you play with Zotero, you'll know how to do this. But there is a simpler way of doing it. The simpler way is install a browser extension. So Zotero has a browser extension, Mendeley has a browser extension. And what you have to do is you basically have to go install the browser extension. You go to the journal web page, and you click on the extension button, and then the citation in the PDF. If you have subscription to the journal, it will automatically get downloaded also into your reference manager. That's a very useful feature. Okay, so let me quickly show you how we can do that. And for that, I'll share my screen here. Okay, I hope you can see my screen. If not, please raise your hand. Yeah, so this is my Zotero screen. And here, what I'm going to do is I'm going to just go to a random journal. Okay, scholar.google.com. And let me open, okay. I'm going to shamelessly plug my own research from the past, but I know that I'll get the citation there. That's why I'm going to do it. Okay. So now we are on Google Scholar. I'm going to click on the journal web page. Right? This is an open access paper, which means that I have access to the PDF also. This is my browser extension for Zotero. I just click it. And it's done. If I double click it, I got access to the paper. And I should be able to see the, maybe if I adjust the view, you'll also be able to see all the information, the author information. Okay, out. Third stat item. Yeah, there you go. Fine. So this is how you can very easily download your Bib files, and then you can go to Word, and we can also try that. Okay, and I've got a Zotero plugin installed. Add edit citation, citation style. Okay, and then I go narrow band and wait for things to happen. It's not happening, not a problem. I got other journals. So I tap that in. I got the first citation, and then I add the bibliography, and there you have it. You don't have to type anything. You don't have to download the Bib. You don't have to go to Google Scholar. It's highly streamlined, right? So you don't have, the younger students especially, because this is really bugging me these days, you don't have an excuse for giving me citations which don't follow a format, because it's too easy to actually do it perfectly, right? So please use the reference manager, download the .bib files, and then everything will be very, very smooth. Okay. Now let's come back to my presentation. Fine. So we've done a quick demo of Zotero. Oh, sorry about that. People here can't see the screen. Fine. Now let's go beyond Google Scholar. Okay. Journal website search engines again. So now the reason why I highlighted this here, catalog the main authors, main journals and conferences, is you don't have to rely on Google Scholar. Say for some reason Google Scholar it breaks down one day. Your research can't stop, right? So what is the other alternative? You directly go to the journal website itself. So we can very quickly do that. I can quickly show you how that works. And one of the faculty members requested I show IEEE Explore. So let's go for that as an example. If I go to IEEE Explore, and then let me just search random fibulases because I'll be able to explain it better. So this is the search engine for IEEE. And then you've got, like in Google Scholar, you've got the full list of publications. But then you also have additional handles here, additional options you can select. You can only select to see journals, you can only select to see conferences, early access articles, then you have the option of restricting, you also have the option Google Scholar, but then here is another interesting thing. You can get the list of authors directly, and here you can see which of the authors are publishing more frequently, right? So now if you just select, you want to see this person, then if you just select that, and if you then just press apply, then you'll only get the papers from that particular person, all right? Then what else? You have affiliation. You can also get an idea of which institutions are more active in this particular area of work. So you can also get an idea from that. And then publication title. You've got different journals and conferences within IEEE. So you can also get an idea of which are those journals where these papers are commonly published. Fine. So this is an example of how you can use the journal website itself, okay, to get into the, to get to know about the journals. So this was journal websites. So use IEEE Explore if it is particularly important for your field of research. Now, the more interesting ones are the more fun ones. Now, while I was preparing this presentation, I came across this very useful or very interesting little open source software, which is called Snowball. This is open source. That's why I put an asterisk. Use at your own risk. Fine. You have to download it from GitHub. You have to install an exe file, and then it works. It works fairly nicely. So what you do is you start with a small collection of papers, which you know, which is important in your field. And then you press Snowball to get similar papers. So you download the Bib files, you create a Bib library, you transfer it to Snowball, and then you just press the little blue button that you can see in the top left corner. And then it will generate like a lot of papers. Then from those papers, you select which ones are of your interest, and then again Snowball, okay? And you repeat. It's basically what you would be doing with Google Scholar also, where you can also say what are the forward citations, then look at that paper and then look for that forward citations. But it's more fun. But it's also a bit, you have to know a bit about your field to know which papers are relevant to you, because here, otherwise you'll have to start reading the papers, which is not, again, it should not be a workflow. This is another thing. When you're doing a literature survey, try your best not to read the papers too much. Literature survey is one thing, reading papers is another, analyzing papers is another, writing a literature review is another thing. Fine? First, sub download karo. Sub download kar lo kyunki wo jaldi hoga. Take that all downloaded things and then do your quality assessment. You can already doing a first level of quality assessment where you are checking the H index, you are checking the journal impact factor, you are making sure the journals are not predatory. So you've already done a rudimentary check there. Download all the papers, it is fine. Then you start filtering. Filtering happens much later. Okay? Connected papers. So we talked about journal websites. We talked about Snowball, which is it's experimental stuff. And then connected papers. This is a relatively new as in maybe like 3-4 years old. This is a web service. And what it does is, this is the beginning of bibliometric analysis. So we'll be looking into more bibliometric analysis. But this is the beginning of it. So on the right-hand side, you can see something like a network. And what it is basically is you take the DOI of a paper. So DOI is a link which is attached to, it's a unique identifier, digital something identifier. It's unique to a paper. You copy that and you put it on connected papers. And what connected papers does is it crawls all over the internet and finds out papers which are similar. And what is that similarity? It shows papers that have highly overlapping citations and references. The chances are that they are talking about the same topic. Okay? Similar papers are closer together, less similar papers are farther away. So what this means is if you download a particular, if you're interested in a particular paper, you know that it is seminal in your field. Like even if it is a literature review, right? You go to connected papers, you press enter, and then it does the job of getting papers which are similar, which have the same citations, right? Problem is, I was trying to put together a few demos for connected papers. They gave me just 5 and they said now pay 3,500 rupees for 1 year. So it is no longer available as a free, it was earlier in beta. It is now a paid service. But it is very useful. And why you should be looking into bibliometric analysis? You should be looking into bibliometric analysis because you may miss a paper. It is inevitable that you will miss a paper. It is humanly impossible for you to scour the whole internet. You have to also write your thesis. You have to also do your experiment. It is impossible for you to scour the whole internet. So you need tools like this to make sure you haven't missed something important. If you know that your literature review is an important paper, tools like connected papers or bibliometric analysis is going to help you. Okay. Now let's get to the pro stuff. All right. So far we were just using some common stuff here, using something found on the internet, but this gets serious now. This is more for MS and PhD students who are entering into a new field. This is more for postdocs who are entering into a different field altogether. Like in your PhD, you'll be doing one thing, in your postdoc, you'll be expected to do something slightly different. And for faculty members, because we are constantly writing proposals, and we are constantly required to write proposals in different areas, right? So how do we write the literature, how do we do the literature survey for such things, and how do we write the literature review for them? Web of Science. How many people have used Web of Science? Here, in the audience, anybody has used Web of Science? No? Okay. Anybody online, have you used Web of Science? Please raise your hand. Okay. Right. So if you have not been using Web of Science, please start using it. All right. Because it gives you a lot more information than Google Scholar. It's much more detailed and it has got a lot more analysis that can be done, even without getting into bibliometry stuff. It does that stuff for you in the background. And most importantly, IIT Mandi subscribes for it. So please use it. Fine, it's a wonderful tool. Please use it. It has got advanced search options. It has got filter options, the same like IEEE Explore. But the other interesting thing is it has got a citation report. Okay, and I can quickly show you what that citation report is. So sometimes it is Web of Science, sometimes it's Web of Knowledge. Either way, it will take you, all roads will lead to Rome, and you'll be able to use it. Fine. Right, so, yeah, remind me. Thank you. Come on. Everything has to happen now. Right. Why not this one? Doesn't have a H-index. What's happening? Oh, no, she had it. She had it. Yeah. So this is the citation report, right? So this is some profile about the author, and this is also verified. See, I got a green tick here, it's verified. And what we can do is we can view the citation report. Now, if you view the citation report, you've got 21 publications, you've got an H-index of 12, and you also see something which you won't get on Google Scholar, which is the total number of times cited and the total number of citations without self-citations. So what happens is when a person is working in a field for a very long time, they also cite their own papers to show precedence of work, right? And what happens when Google Scholar calculates it, it doesn't take into account these self-citations. So what Web of Science does is it actually takes into account these self-citations and it shows that this is without the self-citations. And there are further analytics. I recommend that you go and have a look at it, okay? There's a lot of things that you can do here, but I recommend that you go and have a look. Now, why am I showing you this? Fine. I'm showing you this because of a reason. And that reason is I'll just quickly stop sharing here. Right? And I'll come to the exporting citation example. I've shown you a demo of how Web of Science looks like and what are the different controls. Let's look at VosViewer. So how many of you have heard of VosViewer here? VosViewer. Anybody online, if you have heard of VosViewer, can you please raise your hand? That has helped me immensely, and I want you all to know that such a thing exists. There are more advanced versions out there. This is free. This is being developed by a university in Netherlands. It has been around for a long time. It's highly reliable. It's the first step towards bibliometric analysis. What it does is it identifies relationships between different journals. And this is very similar to connected papers, but you get more. What are the possibilities? Okay. Now, this is where, this is why I said this is the pro stuff. When you're doing a literature survey as a student, your supervisor will tell you, yeah, this is the topic, this is the literature review, go and do your literature survey, right? But when you're working as an independent researcher, you'll be given a topic or you'll be going to a new research group. You will have to find out this information. What bibliometric analysis allows you to do is it allows you to find out research groups, right? Existing collaborations, research offshoots. So you might be doing something like LiDAR, but LiDAR can be applied to agriculture. LiDAR can be applied to autonomous navigation. It can be applied to communication between drones, right? How do you know all of that in one shot? You can do that using VosViewer. Find key journals in the area. This is again another problem, right? So when you're starting in a new field, you don't know which are the key journals in the area. This helps you to find that out. And find similarities between different research areas. And this is bibliographic coupling authors. So now we can do a not so quick demo. Fine. So let's take this example of LiDAR and agriculture, right? So I want to enter into the field of LiDAR and I want to use LiDAR for agriculture. What I'm going to do is I'm going to type LiDAR here and all fields, agriculture. I just want it to be, I'm not putting any filters now, LiDAR and agriculture. 2,490 citations or 2,490 papers. So you can look at it here. How are you going to analyze this? What you do is you go to export, you go to plain text file. Once you go to plain text file, you go down and you go full record and cited references. Okay. Now, when you do that, you can see that you can download only 500 records at a time, right? So what you do is you go here, you say 1 to 500 and then press export. So it downloads a text file and that text file has information about not only the journal, but also the citations. So it has a full record, right? And you do it for 5 times in this particular case because you have 2,490 papers. I've already done it for you. This takes about a minute or so. I've already done it. Okay. So now let's look into VosViewer. So this is how VosViewer opens up. And what we are going to do is we are going to create some maps. That is bibliometric analysis at the end of the day. Just like you saw in connected papers, you can do it for free. Okay. You need to have a Web of Science subscription, of course, but you can still do it for free. So what we are going to do is we are going to create a map based on bibliographic data. Next, we are going to read data from bibliographic database files. So we are going to use Web of Science here. So we choose that option. And then we go to the files that we have downloaded. The files that we have downloaded are right. These are all text files. So I'll select all of them and press OK. and then I press next. So it takes some time to build this, not a lot of time. Okay, and now you have got a couple of options. Okay, now I have kind of weeded out the most important ones that you can start with. There is a lot more you can do here, but let's start with the examples that I talked about earlier, right? So co-authorship and authors. So finding prolific research groups and networks in the field, right? So if I have co-authorship and authors, you got full out, the maximum number of authors per document is 25. That is, in a paper, you'll have maximum 25 authors. So the gravitational wave paper gets kicked out. But here we are not working on gravitational waves. So next, minimum number of documents of an author. So typically, a good researcher will publish at least 5 or 6 papers in an area, fine? Continuous, like even a PhD student, you publish 5 or 6 papers and then you get your PhD. Minimum number of citations, you want the paper to have at least 5 or 6 citations, right? So you push it up. Let's push it up a bit more. Let's push it up to 10, right? 11, 12, 13, 14, 15. So you see that 313 papers meet the threshold. And now you see the number of papers coming down. So you have got 307 only. So let's just bring it down a notch. So this is kind of the average good paper. So next, you have got fine. It will select 300 authors. You get the full list of authors and then you press finish. Then it says that 308 items in your network are not connected to each other. And it consists of 232 items. Let's do both. So let's just say no. Right? And then you have something like this. That background. So here what you have is connections between the authors. So what we started off saying was, we wanted to find the prolific research groups and networks in the field. So you can see here, which of the authors are actually working together, co-authorship. They got some isolated authors here, and you've got some authors here who are working together, which means that now you can look for those specific authors in your Google Scholar and recover those people, right? And you know that these people are working together. You know that if you know Taroli is working with this group and that group, so you can do an analysis like that. So that's co-authorship networks. Then we can do countries for finding collaborations. That's straightforward. Documents. Let's do this. Bibliographic coupling, or let's just do it for completion. So we can go again. Now the files have already been loaded. The next example is we go co-authorship and we do countries. So this will tell us which of the countries are actually working in this area. And we say maximum number of countries per document is 25. We don't worry about that. Minimum number of documents of a country is 5. So you expect if a country is working prolifically, you will have a lot more. So we have put 5 here. Minimum number of citations of a country, here it's 0. If you even push it to 10 or 20, it doesn't make a huge difference because of the number of papers a country would publish. And you will see which of the countries are actually publishing. And then you go finish. And then what we can do is to highlight which of the countries are more prolific. The lines, size variation. The USA is working a lot in this area. You've got People's Republic of China, you've got Italy, you've got Spain. Now you can also see, yeah, I'm short-sighted, I need to take breaks. Fine. So you can also see which are the countries, which other countries USA is working with. So you see all of this network. You can see how China is collaborating with other countries. You can see how Italy is collaborating with other countries. So you can see, you can start building a more broader perspective of the relevance of the research. So that's why it's a bit more involved. It's more for faculty, it's more for active researchers. So this is one thing you can do. What is the other thing you can do? You can do bibliographic coupling and documents. So let's do that. Identifying key research offshoots. Now we get to the interesting stuff. Bibliographic coupling. This is the same as connected papers. Okay, now you are doing it for free. You don't have to pay 3,000 rupees a year. Don't tell Connected Papers. So now what we are going to do is we are going to go to bibliographic coupling and documents. So it's already selected. Sorry, it's already selected. Next, minimum number of citations of a document. So you want it to have at least 10 citations, right? Some quality check is required. So you do that. Press next. Number of documents. It just does something. Don't worry about that. And then you have your 990. Just go. In this case, I'll just go no and see what result it gives me. Let's see what happens. Oi, oi, it's taking a long time. I wasn't expecting this. Okay. This particular paper seems to be completely out of the field, and that's why there's a lot of distance. So what we'll do is, for a better visualization, I'll just run this algorithm once again. So now I'm going to, the largest set of connected item consists of 999 items. Do you want to show this set of items instead of all items? Yes. So I'll just check the closely connected ones. Now we are in business, right? Now what I'll do is I'll just bring the size variation down a bit. Okay. Now what you're seeing here is actually a whole map of the research area itself. It's 2,400 citations, quality checked, making sure that you've got some good papers in there, and then you've got a clustering analysis. I don't know what is the algorithm that you use. I won't comment on that. I'm not an ML deep learning guy. But what you have here are clusters. And these clusters will tell you what are the research areas. How do you get into this cluster? Look at the extremities. Okay. So if you look at the extremities, and let me just zoom in a bit. Right. So if you look at these extremities, you'll see that you can also see the details about the journals. So you're seeing that it's a laser scanning to track canopy height of both monocot and dicot. Fine, all right. Then you've got multi-temporal crop surface models, plant height measurements, and biomass estimation. Fine. Then you have leaf area estimation in vineyards. So you've got a couple of agriculture-oriented papers here. Fine. Ultrasonic ranging sensor and apple tree canopies. Okay. Now I'm already coming close to what at IIT Mandi we would like to do. We'd like to do something related to apples, right? So we already have a hit here, right? We can look at the other end of the extreme, right? Let's look here, or maybe here, fine. So if we look here, this is about modeling forests. Now we are entering into the forests area. We are entering into forests area using airborne lidar. So we're looking at extremities. Extremities are a good indication of where that field lies. So predicting forest stand characteristics with airborne scanning laser using practical two-stage procedure and field data. Fine. Now, if you look at this end, positional errors, modeling, growing stock volume. I don't know what this is, but clearly these are clustered papers. These are papers which have a common citation list. These are papers which are citing the same kind of papers. And that's why they are getting clustered together. Right? And now if we move to the other extreme, geomorphology. So LIDAR in agriculture, that search in Web of Science gave me 2,500 citations. And now when I put those citations here, I'm able to analyze what are the research areas. That's something fantastic. I've been able to do in 10 minutes what would have taken at least 3 to 4 weeks to figure out, right? So very, very useful tool. So that was bibliographic coupling and documents, bibliographic coupling and sources. Oh, I didn't show you the most useful part of it. Let me show you the most useful part of it. Let's zoom out a bit. Okay. NASET seems to be an important paper. Fine. So what I'm interested in reading this paper. Do I go to Web of Science, search for it? Or do I go to my reference manager and search for it? No. Click it. It opens the paper. Right? Life made easy. More time for Netflix, more time for Prime Video. Right? Work efficiently, work intelligently. Right? It's good to put effort, but when tools are available, use those tools. All right, so now we have this. Let's move on to another example. Now we have done documents, we have done sources, key journals. We want to identify key journals, fine? Sources. Minimum number of documents per source, we want it to be at least 10. Fine. Number of citations, we want it to be, again, let's say 10. 50 sources meet the threshold. So here sources are the publications themselves. Next. Next. Okay. It's not very clear which are those journals which are important. Fine. Adjust the size. Remote sensing and environment, remote sensing. So what this map basically means is journals from remote sensing, that particular publication, that particular journal, are citing papers from these other journals. So that is what this means. You got remote sensing, which is citing, you got geomorphology, which is citing all these papers. So again, you get a sense of which papers are going to be the most important in that field. I will leave the final one to you because I would also like you to try it out. Right? The final one is bibliographic coupling authors, similarity between research areas. So this is a bit more nuanced because it means that authors are more or less working in the same area, and that has to be cross-correlated with the research areas we found out earlier. Right? So this is a bit more nuanced, but it's worth a shot. Fine. So this was VosViewer. And what VosViewer allows you to do is to immediately get into a field to identify what are the different research offshoots in the area, who are the most prolific contributors in that area, how these contributors work with each other, how many of them collaborate with each other, which countries are actually working in this area. All of that information is available to you. Fine? All right. So this was VosViewer. And stop presenting here. Right, so we did a demo of VosViewer, right? And now you have in your arsenal a couple of very useful tools. You know now how to use your reference manager. You know now how to use some of these journal search engines. You know how to use Snowball, and above all, now you know how to use Web of Science and VosViewer for really advanced analysis of research. All of this is still now it's information. You wanted to convert it into knowledge. What I mean is you want to go from a reference manager eventually to something like this. You want to write. You want to write a paper. You want to write your thesis. How do you do that? And the first step towards that is archiving your research. A very important skill to have is speed reading of journals. Okay, this is what I usually do. I have my reference manager open. I start reading the papers. I first read the abstract. I read the conclusion. I read the last paragraph of introduction because it tells me what the scientist or what the researcher is, what's the strategy, what's their strategy, right? And then I examine the figures. If a paper is really good, you don't even have to read the paper. You just have to see the figures. If the figure results match what the abstract says they are going to do, that is a good paper. Take it. First shortlist kar lo usko. Put it in your reference manager. That's your first snowball list, right? This is how, now you have to decide if this paper is important, right? This is where your thinking comes in. So first of all, you see that, okay, fine, this is a good paper. The next level of snowball is, if this paper is important to you, so you have to reevaluate if the work aligns with your research, if the claims align with the findings, and the strategy used by the authors is sound. This is more advanced stuff. Again, what basically I'm trying to say is, if you get a paper, try to think how you would be doing the same thing. If it doesn't fit, maybe there is something not quite right, or maybe you don't understand the concept. That means you have to think a bit more, right? And move to a separate archive folder to read later. This is for later deep reading. Deep reading is a completely different ball game altogether. I'm talking about speed reading. Deep reading is completely different. And repeat for the next journal. So you keep on doing it, okay? Now here's the bit. When you're doing a literature survey, according to you, people who are here in person, can you tell me what is a good number to start with? If you're starting a literature survey, when will you say that, okay, this is a good list to start doing speed reading? What is the number of journals, once you have it in your reference manager, you think is a good time to start speed reading? Third, at least 20, okay. Any more? 40? 42. We have got a Douglas Adams fan here. Anybody else? Iqbal? Okay, around 100. So Iqbal is a PhD student. So yes, 100. That's a good number to start with. Anybody in the audience, what number do you reckon? You can share it in the chat window if you want. So just to get a feel of it, I was asking for this number. I start with 100 to 150 journals. That's when you start doing your speed reading. Before that, you just collect. Blindly you collect. You're doing your quality checks and all that. You know that the papers you're collecting satisfy a particular threshold. Take all of it in. But you start speed reading after you have 100 to 150 journals. Then you read it down to 75 or 100 more important ones, of which 50 appear in the final version. This is for MS and PhD students, not for BTech students, not for MTech students. That's a different ballgame. But typically you should be starting in this number, in this range. 100 is a good number, okay? It might seem it's going to take you a lot of time, but believe me, 3 days, not more than that, okay? Now that you have all of this information, what do you do with it? You have to convert it to knowledge. And this is one technique I use. I have found it, I have used a modified version of it, but this is a good starting point. Just use Excel. Or kuch nahi chahiye. You don't need anything else. Just use Excel and structure the information that you have found it. You have now weeded down your literature review to 50. At that point in time, you have to start reading the paper and you have to start finding out what are the important points there. So what do I mean by that? So if you look at the different columns of this Excel dump, right? You've got the concept, you've got the citation link, and you've got the main idea. So those are the different columns. You've got the concept, what is the paper talking about? You've got the citation link, also maybe the title. You can add a title. And what is the main idea? The main learning of the paper, the main result of the paper. And you've got notes 1, notes 2, notes 3. Typically a short paper will have like 3 most important takeaway points. Add that to your Excel dump. Important cross references. This is like a Netflix kind of a thing. So if you like this, you'll also like this. So add a couple of cross references which are directly related to this paper. Fine. And then some important quotes. Sometimes you might find something really well written there which you want to use later, or something that makes most sense if it is reproduced in the way the author has written it. Fine. So you add those quotes, and for sure, you add the year, okay? That's important for chronology, precedence. Why do we have to do all of this? Again, this is the concept of that second brain. You cannot keep all of it in your head. It's simply impossible. With the amount of distraction that is going on these days, with the amount of commitments that you have, each student I've seen is doing a lot of things which they should do, but which means that they need to have a system in place. This is your system. You have to kind of offload that thing so that you've got space in your brain for doing other interesting things. This is interesting, but there are other interesting things also. So it helps you to condense the information on the papers. It helps to filter and compare across papers of the same concept or genre. You must be able to do this. It helps to condense for sure, but the information that you get out of it, you should be able to compare across papers. Especially if you're doing research, this is a very important thing to do. And it helps to write your literature review, okay? I can give you one example of how you can start writing a literature review directly from here, fine? So say you've got this and you want to assess technologies across the years, right? What you will do is you need to use some tools, okay? What I do is I use something called SWOT. So you use SWOT for decision making in management and all. But you can also use these management tools and you can transfer it across. Here you can transfer it across to writing. So what I'll do is I'll say that what is a particular technology, what are its strengths, what are its weaknesses, what were the opportunities, and what are the threats or challenges. A better option is SWOT. So SWOT was flipped over for SWOT because it's more optimistic. And challenges, when you start talking about challenges, what you are saying is, this technology is good, but it doesn't allow me to do this. But then there was this next technology which allowed me to do that. So what you can do is, XX is one row of your CSED, of your Excel dump. YY is another row of your Excel dump. And you just have to put articles and prepositions together and adjectives if you want. And then it is structured. So here I'm saying that XX et al. Demonstrated XX technology in 18 something. They're able to show that Note 1 and Note 2. However, the primary limitation of the technology was Note 3. In contrast, YY et al. Showed. And then you have got 500 words like that, right? There is a lot of groundwork to do. It's not easy to write a literature review, but it's not impossible. And it doesn't have to be boring. It doesn't have to be lengthy. It doesn't have to be exhausting. It doesn't have to be tiresome. You can simplify it. You can make it fun. And this is how you make it fun. I've got more writing tips here. So I shared this with all my PhD students and master students, and I also share it with you. This is in my website. And there is also a YouTube video. Last year in November, I gave a YouTube video to, I gave a YouTube talk to your research SCRI. And this was about this constructive alignment. Stop thinking, start writing. So there's even a YouTube video out there. So you can check that out. It's a 1 hour YouTube video, not 1.5 hours like this one is going to be. And finally, when? When are you going to, when means not when now or later, means how frequently you should be doing it. And the simplest answer is always. If you are working actively in a research field, you have to keep up with the literature survey, right? It's not that the first 6 months are literature survey, done, literature review done, and I'll start doing experiments. Nahi hoga. Okay, because things are keeping on happening. You're doing an experiment, suddenly you'll come to know that somebody in Germany has already done that work, like yesterday. And then you have to start thinking, okay, now what did they do? How am I going to change my research? So you have to keep track of it. That is serious FOMO. You have a fear of missing out at all times. This is something all of us researchers live with, but we also have to find coping mechanisms. The simplest coping mechanism is, yeah, well, they have done it fine. What have they done? How have they done it? What are we doing? How does it match with them? And what we can do to make it slightly different, but also add to that body of knowledge. It's an ongoing challenge, but we have to meet up with it head first. So how do you do it? Keeping track of state of the art, okay? Setting up alerts. I don't know how many of you are using alerts, but if you aren't, and if you are in your second or third year of your research, master's, second year, especially for master's, it will be second year. For PhD students, second year, third year, you have to set up alerts. So if you find a particular paper interesting, you go to the journal website, you go to IEEE Explore, you have an option for setting an alert. You can Google it, you can find that out how to do it. It's fairly straightforward. You will get an email every time a paper is cited, a particular paper in your area is cited. How much more easy can it get, right? You'll get an email. You can use RSS feed viewers. Now, this used to be all the rage back in the day. I don't know if people still use RSS feeds, but IEEE Explorer and all of the major journals offer RSS feeds. You see the small kind of a antenna kind of a thing here, this radiation pattern. That's the RSS link. You click on that, opens up a huge kind of a thing. But you can use these, again, RSS feed viewers, which are Feeddaemon and Feedly, and then it will just transport all of that to your feed viewer. And you can see what are the journals published. And this is another easy way of keeping track, because once a journal is published on the website, immediately you will get your RSS feed saying that this journal has come out. Okay, very important, especially for the seminal journals in your field, like Nature or Nature Communications. You need to have them. You need to know what's happening out there, right? And this is a screenshot of my own. I use Feeddaemon. Feeddaemon is no longer supported, but this is the most non-cluttered thing I've found out there, and I keep on using it. So this is all the list of journals that has come out in a particular journal. Social media. If you're not on social media, if you're not active on social media for professional purposes, get on it. A lot of people are now on social media. Gone are the days when people used to think, oh, it's a time waste. They're using it to actively advertise their research. Twitter, if you follow the most important people in your area, the moment they publish a paper, immediately it goes on Twitter. Okay, there is almost no delay. So follow people, follow the scientists on Twitter, and then you'll immediately get an update from them. So this is kind of, this LinkedIn and Twitter is replacing RSS feeds. I don't know how many of you do it. I must admit, I have not done this in quite a while. The first page of journal websites, they have the most recent research out there. If you're not doing it, please start doing it. It's like just when you enter into your lab or your office, just open the first page of the journal and see what is happening in that particular field. Like IEEE has got a very nice first page. Nature Photonics, Nature, they have got a very, Nature also talks about science policies. So first page of journal websites. And then submit to and visit conferences. This is very important, because in conferences you'll meet people who are working in your area who are also the same age as you. And that's the best time to start cultivating your network. Okay? Immediately they'll say, hey, I'm going to publish a paper like this. What do you think? They might also come and kind of discuss with you. You'll have collaborations. This is why you should go to conferences. Conferences are important because it tells you what is exactly happening, what's the next thing that's going to happen. There's going to be a lot of noise, fine? But amongst that noise, you'll find that one thing which will lead to the next best technology out there. And your skill lies in finding that next best thing. And how will you find that next best thing? You have to do your literature survey. Because then you will know which is noise and which is a data point. Finally, in summary, I'm sorry I overshot a bit, but again, the video is being recorded, so I hope it will be useful for posterity. In summary, what we started off with was we established why a literature survey is important, right? Not to reinvent the wheel, but also to become an expert in the area. How do you judge papers are good or papers are bad? You look at metrics. The author H index is one metric. The journal impact factor is another metric. These are good metrics to start with. Okay? How do you kickstart your literature survey? You find a good review paper. Now this actually links back to VosViewer, because in VosViewer you will find invariably the largest bubble that you find is going to be a literature review. That is the best literature review paper in your area. Reference managers, use it. End of story. And then you can use tools which are connected papers and VosViewer. We talked about VosViewers extensively. And finally, how to change information to knowledge. This is what wraps up your literature survey. The literature survey doesn't stop at Zotero. It doesn't stop at connected papers or VosViewer. It doesn't stop at speed reading. It stops at this. It stops at the synthesis of that knowledge, right? And this is where I also stop. So thank you very much for your time, patience, energy, and I hope it has been useful for all. Thank you very much.